Hi everyone, I am Saniya, and in this video I want to talk to you about how you can use the grep commands in Linux to do exact searches for terms or whatever you are interested in, especially from very, very large data files. So how can you hunt using those commands? So let's get started. So here we have this file that's PGC, Psychiatric Genomics Consortium 3, so it's just a wave of Genome Wide Association Studies for Schizophrenia that was just released this year in 2021. So I want to let's look at it, for instance. So if I click it, what does it say? It says, uh-oh, this file is too large for Notepad. Uh-oh. Use another editor to edit the file. I just want to look up information on a SNP, a single nucleotide polymorphism from here. So how do I do that? Well, fortunately, if I have Ubuntu installed, I can just, go here. So this is the file location. I can do cd/mount/C. That's going to mount my C drive, which is what this is here. So I'm just going to navigate to this folder here. And now within the downloads, what you're going to see is this PGC SCZ wave. So what I can directly do is to see how many lines are in this file. I can just do the following word count /L, and then I can type this. PGC3.txt. And what this is going to tell me is that I have about 7,585,078 rows in this data set. That's a lot of rows. So if I just want to see head and maybe the first 10 rows of this data set, I can just do .txt. This will show me the first 10 rows of this data set. So you can see here that what I'm interested in is kind of, it's splitting into one line. Okay, it is what it is, not the best in a way, but you can see chromosome. Let me close this operation. Let me just close this out here. Okay, so you can see chromosome, SNP, base pair. So I want to look up a particular SNP of interest as well. So there are all these features here that are measured in a genome-wide association study. And it can be anything. This is a GWAS. And a SNP is just equal to a single nucleotide polymorphism, just one DNA base being different in at least 1% of the population around the world, which is pretty huge. So this can be any file, anything that you're looking into, but I just know that these files, because we have billions of base pairs in our DNA, that these files can be really huge for SNPs. Like this file already has like 7.5 million rows. It's a lot of data that it has, like so many rows of data. So this is to view the first 10 rows. If I wanted to just view the first 3 rows, I would just change this argument from 10 to 3. So that's just the number of rows you want to see. So, you can see that the top row is always printed out here. And so this is the top row. It's sort of spilling into the next because it also has, it's just the name of headings. Then this is the second row. And this is the third row. So it just looks like this. And so each of the row, that's one row. The next row is like this. It's just spilling over because of the screen size. And this is the next one over here. These are just the 3 rows. So looks like a traffic light a bit. And you can see this is 3. And this is 3 rows. Now I want to kind of look within all these 7 million rows that I couldn't really open up in the text file, even though it's a text file. I can open it up in R, Python, Java, other softwares and language editors as well, and programming languages. But if I just really want to quickly see what is inside this, very efficiently query it. So again, these are the different rows here, first row, second row, third row. So, and just to prove it again, I'll just also show you if I just do the first row, I will get just the headings. Now, in the second row, I'll just get like those 2. So I want to look up this particular SNP. The goal is to find the SNP that is given by the SNPs here are typically given with an RSID number. It's just some identification number. So if I want to look up RS1163 0760, get the rows of information related to this SNP, then what I can do is I can use a command called the Grep command in Linux command line, or also known as Ubuntu, which in Windows Subsystem for Linux. So I can just do grep, and I have to put what I'm looking for, which is the SNP 11630 and then I have to put the file where I'm hoping to look for it in at ext. So it's going to hunt. Okay, so it's basically looking for, this is the term you're looking for. This over here is the file. This is the file name that you're looking for it in. And this is what you always need. You always need to have this grep command here, this star. So that's sort of how it works. So you have the term to look for, the file name you look for the term in, and you need to have this grep, G-R-E-P, grep. You need to have grep. So then based on that, now you will notice that we have this row that has, well, it has the same term, but it also has a 2 next to it. So it's not quite exact. Neither is this, but it shows me everything as long as it contains it inside it. So like if I look for, but I also get the exact term which I want, which is this. Like if instead let's say I added a 2 to this, like I add that 2, I'm only going to get this one row here because there's only one of its kind. So anyways, I'll go back to the you really just want an exact term hunt because you Genome Wide Association Study. So if you want an exact find, what you need to do is you need to add in to the term that you're looking for, you need to add in the following. So if this is the term, you're looking for, it's in quotes. So if that's what the term, if that is what you're looking at, right here, it's in quotes. Oh, wait, let me put it like this. If this is the term you're looking up, then if you want to make it exact, what you need to do is you need to put instead something that's known. If you want it to definitely be exact, you need to add in /b in front of a term to look up, and then /b. So you just need to add this. Why? Because this will make sure, it is going to be an exact find. This will make it an exact find. an exact find for you. So if you want to only make sure, basically this is an exact, it needs to only have that. So what you're going to get from that is you are trying to isolate only this row. Otherwise, what you're going to get is you're going to get all three of them, as long as it contains it inside. As long as this RS116307060 is inside it, it would just return it. And that's what you get if you just look up this term by itself. But if you only want it to be an exact find for you, just the exact find, then what you have to do is you just have to add //b in front. Because if there are duplicates, you know, like you may end up with this situation where it's unique, not unique, but there's no other one that has like, it's not like there's RS11630766021 or 25 or anything else. It's the only one that there is. But for this one, you can have additional stems, like you can have this one above with an additional 2 after it, additional 2. So you do need to then specify with the //b. And also the R version of this too, you can also use //-b as well for exact finds. So now what you're going to see is, yay, we have the exact find. So we have the exact row that has this inside it. That's great. So we have this exact find indeed. So all you need to do, if you want an exact find, what you're going to need to always have is the following. You're going to need grep, you're going to need grep //b, and then //b after, and then the term to look up is inside here. This part is the term you want to look up. The term to look up comes inside here. And then again, this is just the file path where the file is. So that way you're only going to get the unique ones. You're not going to get anything else. You're only going to get that one, you know, by itself. So you can add the //b. So that is how you can look up unique terms in using grep. So again, whatever you want to look up, you can easily do that this way. You know, you have the term. If you want multiple ones, as long as it has it, you can use this. If you want an exact find, then you just have to add //b in front of the term to find and be after the term to find, all in the quotes. So that's how you can find things very quickly. And this is super helpful if you want to just quickly browse like a database, you know, if you want to just identify any information, you know, like if we also want to look up this, you can also look up this too. I'll show you another example. We could look this up too. Let's try looking up this SNP here that is related to RS3. Let's look up this one here. Ooh, RS3134156. And it happened to be one of its kind, so it doesn't make a difference here whether or not you have the //b in front or not. It doesn't matter. But for instance, if we just like slash off from this one above, you know, we get this row here, but we could also get like, we could also slash this off here, and then we can get many, many rows that have, you know, if we just slash off from this here, if we just slash off one of the endings here, if we just slash off the ending, we can see all the SNPs that have this as the stem to begin with. So then we could see that we have an exact function over there. And this //b, it's just mainly like whichever part needs to be exact. Like if the to look up needs to be like always ends like that. Then you can put the R, then if it's some number you wanted to end in this always, then you put the //b here. If the ending needs to stop at the term to look up. So if you have a term to look up, you have this in quotes. If basically, if there is, you have to see, can there be any additional part after that? Like for the SNP, can there be any additional numbers after that? If no, if that's not possible, if you don't want anything after that, then you need to add, if you wanted to definitely end that last letter in the term to look up, if you want this P, for instance, to be the last letter, you need to put a --b there. If you want nothing to follow that. If on the same vein, there could be some text before this, like but it's not the case in the SNP example, but let's say that you could have a SNP starting with like an A, like, or a BRS, and then some number. And you don't want that. You only want it to start with RS number. Again, that's not possible because SNPs start with RS numbers, but let's say it could start with a B and you don't want that. Then all you have to do is you just have to, like, if you don't want it to start with anything like that, you have to just put a //b in front as well. But in SNP, so in the example that we did, it wouldn't have mattered so much about this part as this part, because there is really no other term in front of the R and the RSID. But if you don't want anything before this in general for any application, so you can put one or the other or both, depending on what part you want to be exact. So like, for instance, going back to this example here, where we got 1 by itself, if we did this, that means nothing should come in front of the R. But there's nothing really that comes in a SNP ID, so it doesn't really matter for us. So that didn't do anything. We still got all 3 results. We only wanted 1. So if instead we could have also just done this, and we would also get 1, because we can just put this //b here, because we don't want anything after that. Because in this situation, there are things after the SNP. After this term, there was a 6 after it, there's a 2 after it. So there's different possibilities. So you want to control this in this situation. But if you really don't know and you just want to have something exact, then you can just by default include this in front and this at the end. So you can just, if you want to be safe, you can just always put this here. So this is, I hope this is a helpful guide for you guys for how you can use Grep to do exact finds, or just a general idea find in a large database, a data file, like even if it has millions and millions of rows and you may not be able to load it directly in Notepad. So I hope that this was helpful, and please like and subscribe my channel if you found it helpful. And please let me know if you have any questions. And thank you to Sankarshan for the suggestion for this as well. Thank you.